Consider the general formula for the Fourier series. f of x equals a naught over 2 plus the sum from k equals 1 to infinity of a sub k cosine kx plus b sub k sine kx. If we look at the following maxima input, you see that we first define f of x as e to the x. We next define g and h of x as e to the x multiplied by cosine kx or sine kx. From there, we can define a sub k and b sub k as they correspond to the equation for a Fourier series. Our next task will be to define f2 of x, which is the Fourier series of e to the x. If we look at that series expanded explicitly to terms not using any functions, we see that it's a little bit complicated and messy. Nevertheless, we can work with it. Using this very same definition, we can define f3 of x as that exact series. You'll notice now that the a naught over 2 term has moved to the right side. We'll now look at the function f3 underscore fin of x, which is the very same function as f3 of x, only with a finite limit. You can see our limit is 25 instead of being infinity. This is an estimation of e to the x in Fourier terms. Since we integrated from negative pi to pi, this series will be periodic on that interval. As you can see, if we plot e to the x as well as f3 underscore fin of x from negative 4 to 4, we have a function that approximates e to the x very nicely. You can also note in this image the periodicity of our Fourier series. We go from negative pi all the way to pi before starting to repeat.